Good evening, everyone. And my name is Adebobola, and I am the direct mentor for the DevOps and Cloud Track at iQube.OX. Previously, we've had a couple of sessions in our community and also in our track particularly, and we've had about 4 sprints in our community, and we've also had mentors that have dived into the shared resources that have been shared by the mentors, and they have also tried their hands on specific tasks and projects. I'll be presenting for the DevOps and Cloud track today, just to walk us through um, previous tasks and activities in our group. And in subsequent sessions, we are going to be having our mentees presenting on what they have learned and also what they have built. So I think we can proceed. So I'll be talking a bit about what DevOps and cloud is, and also about what our track is all about. In our track, we also have a cybersecurity sub module, and so we have 2 modules in our track. The first is the DevOps, and the second is the cybersecurity. We are pulling these 2 modules inside the same track because they are interconnected and they basically work using the same or similar concepts, tools, and processes. Yeah. So I think I should start with what DevOps and track means. DevOps and cloud is. DevOps isn't just about the codes that we can write or the scripts that we can write, or how good or how skilled we are at something. It's basically a mindset, a set of practices, and I also like to refer to it as a cultural philosophy. It merges software dev, which is where the dev comes from, and also the IT operations, which is where we have the op, and it has a simple goal, which is to simplify, automate, and integrate processes that enables faster, safer, and more reliable software delivery. In our track, we are going to be focused on building foundational skills that are required to operate, secure, and manage modern systems and infrastructures. We are not going to be starting from advanced tooling or complex pipelines or complex scripts. We are deliberately trying to ground our learners, members, and mentees in our track in how real-world systems actually work. Our emphasis in this track is on Linux systems and basic system ops, and also cloud fundamentals and infrastructure concepts. And this basically is to ground us in skills that are used in real-world scenes, production environments, and cloud platforms. Over the last 2 sprints, between our last OX session last month and this current OX session, we have talked and learned on terminals, and we worked mostly on 2, PowerShell and Bash. But we had a focus on Bash. Bash is actually a Unix-like shell, and it isn't just an interface or a command line. It is also a programming language that allows us to write Bash scripts, and which is why we are focusing on Bash, because it allows us to navigate Unix-like systems. And we also talked about PowerShell because it is a cross-platform usage, and some of us might be familiar with it on our Windows operating systems. And then we also talked on basic navigations, file and process management, permissions, and package installations. Then we also tried our hands on a practical task, which involved us installing and configuring our Linux machine. This could be done in a number of ways. Could be through a virtual machine, or it could be by configuring a virtual private server, or through a local virtual machine. We talked on this in previous sprints, and we'll also have members and mentees that tried their hands on this. And also in subsequent sessions, we are going to be having mentees, just like I mentioned, walking us through their Linux environments. So over the resources that were learned and also what we did over the previous sprints, we also delved into editors. This could be terminal-based or graphical user interfaces, and these are basically to create and modify files and scripts. We also talked about process and performance monitoring, and this could be done in a number of ways using commands on our terminals. It could be simple commands such as stop or df-h, and this is basically to monitor our CPU's memory on our server. And also, we also talked about networking tools. This has also been explored previously in one of our sessions and in one of our sprints. This could be done using tools such as Nmaps or Zenmap, and this is basically to inspect connections, port, and services on our server. And the interesting thing about all these connection ports and services is on a Linux server, they are all treated as files, and a simple way to list connection ports or services on our server is one of the simple commands to use is lsof, and this is basically to list open or running services or files, as the case may be on our server. We also touched on text manipulation, and this involves different processes. It could be those as simple as just viewing a file. We could view a file using either our cat or our top or our tail, or it could also be by editing or modifying existing files. So we also worked on tasks and projects over what we've learned over the past few sprints, and to effectively work on these tasks, there are some background skills or knowledge that are needed. Our track is actually beginner friendly, and it doesn't need us to be grounded in complex skills. I think the first one is basic computer literacy, and it could be just simply navigating our existing operating systems. Most of us are working with a Mac OS or a Windows OS, and just simple skills about navigating our existing operating systems. And also when we've been able to set up our Linux OS, Ubuntu OS, also about navigating the environment, and also about command line awareness. These are basic commands to create a file, switch between directories, and could be also simple setting up users and also permissions for a specific user or a file, and also about networking fundamentals. Okay, yes, so I'll be walking us through some of the resources also, but I think I should complete this. So for the networking fundamentals, for us to be fully grounded in more advanced tracks or skills such as our AI or ML, or it could even be our DevOps and Cloud, I always advise members or mentees also to have a basic knowledge about how backend systems work, because everything basically works over the internet or over networks, and our internet is basically a network of computers that are communicating over the internet, and we need to know how these computers communicate and how data and packages are being shared. Okay, I would double back on this. Then also we need access to a Linux environment. Previously I talked about members setting up their own Unix or Ubuntu servers. This could be done either by setting up a virtual machine or by owning a virtual private server, or it could even be cloud instances that could be created and easily destroyed. And of course, we all need to be willing to learn and experiment because, as they say, no one is perfect. And we are all going to make mistakes, but mistakes doesn't mean we are doing something wrong. It's basically you are encouraged even to make mistakes, but you also need to make the mistakes and then ask yourself the question that what did I do wrong? And also about documenting and finding ways to clear your blockers. And we also encourage documentation. That documentation is also a key aspect of our DevOps and cloud track. Some of the project and tasks we worked on over the previous sprints, and these are some compiled tasks that members are encouraged to try their hands on. And outside of this, members are also encouraged to try their hands on personal tasks and projects, and also encouraged to share their progress, learning, and what they are building with the rest of the members in the community. So these are some of what I have talked about previously, setting up a Linux machine, configuring user access and authentications, installing essential packages on our servers, monitoring system processes. This could be our CPU, memory, and disk usage on our server, and also analyzing system logs, networking tools such as our mmap and zmap to inspect connections and open ports, then text manipulations, using simple commands such as cat or tail or top, or searching. It could even be searching for a specific text or string in our files or in our directory using the grep command. And we are also advised to document our system setups. And of course, we are encouraged to try our hands, not just learning, but also knowing what each Linux command means, and also about experimenting it on our own Linux machine. It could be simple commands such as navigating files or directories such as cd, or just basically creating files or granting user permissions, basically. Then for skills and potential career opportunities, for people that are skilled in tools and processes that are used in real-world DevOps environments, basically the first one is they should be able to set up and manage a Linux server, and also definitely monitoring their system performances, monitoring and also able to view and analyze their logs, and also about troubleshooting networking and infrastructure issues. And of course, all these are easily done by documenting what we work on. Most of the issues that are being encountered in real-world scenarios, most of these issues are actually reoccurring. And instead of just when an issue occurs and we are just trying to run and finding a solution, it is easier done if we know that we've encountered a similar issue before, and we could easily access the documentation and recreate this solution that was used to solve that particular issue. And potential career opportunities for people that are grounded in DevOps and skills, DevOps and cloud skills. First, they could work as DevOps engineers. DevOps engineers basically are people that are engineers that bridge devs and operations by automating and streamlining the software delivery cycle. They focus on CI/CD, infrastructure security, and collaboration to deliver reliable software faster. And also, they could work as cloud engineers. Cloud engineers basically are engineers that design, build, and maintain cloud-based systems that help manage businesses and their data applications and infrastructures. They could also work as site reliability engineers or systems and infrastructure engineers. And this is probably the last slide in this deck. For documentation, like I have been saying, documentation is a core part of our DevOps and cloud learning process. Members are encouraged to clearly document their work to reinforce understanding and support collaboration. Simple things we could document in our personal reference or portfolio are basically how we are able to set up a system and also configuration steps, commands and what they do, their functions, and also challenges that are encountered and how we were able to resolve them, and also link to resources or external materials that are used. So we have people that are joining the community daily or on weekly basis, and I don't want them to be worried about where to get started from. In our DevOps and Cloud track, we actually document and create all our resources in a Google Drive repo. And for the two modules we have in our track, we have the DevOps and Cloud, and we also have the cyber security. Each of these modules have their own curated resources in a Google Drive folder, and we can easily access this. In our cybersecurity module, we have been through 4 sprints, and this is also the same for the DevOps and Cloud. So we have curated resources that we can easily go through, and also curated tasks and projects that we can try our hands on. Okay, so speaking about backend systems and understanding how computers communicate on the internet and how data and packages are being shared, there is a little GitHub README file that is being curated, and I will also be sharing the link to this repo to our track. And this is basically to just walk us through some of the processes in our computer, internet, and networks work. Yeah, so moving on to the next sprint in our DevOps and Cloud track for next week, we are going to be talking about version controls and containers, such as Docker, and we're also going to be trying our hands on Kubernetes. Even though this might be a little bit advanced, but it's just about understanding the basic processes about how containers work, and also version controls on GitHub, using GitHub. Yeah, thank you everyone, and hope I've not taken too much of our time. So if there are any questions for me, I think I'll be taking that now or at the end of the presentation. Yeah, thank you everyone.
Thank you, Adebobola. Do we have DevOps mentees in the call, on the call rather? Tosin, what track are you in? Are you in the DevOps track?
Yes.
What track are you in, please?
DevOps and Cloud.
Oh, DevOps and Cloud. Okay. Do you mind giving an overview of what you've learned so far, or did you just join?
I just joined.
Okay, that's great. So you've had an overview of what you'd be learning in the DevOps track, and I hope you're excited. I will see more of you, and hopefully by the next sprint, you'd be presenting. Okay. Thank you. Ogogo, your hand is raised. Do you have something to say?
Yes, good evening, everyone. A question to Adebobola. What's the distinction between a cybersecurity person and a DevOps/cloud person? Like, what's the distinction? Did anyone get that?
Yes. Adebobola, did you get the question?
Apologies, I've been talking. Can you hear me now, please?
Yes.
Okay, great.
Yes.
Thank you for your question, Paul. So a DevOps engineer basically is tasked with activities such as bridging the gap between devs and also operations. It isn't just enough to build an application on your local machine or pushing your code to GitHub, you are also required to push your applications to users. And this is also an aspect of what DevOps engineers do. They automate the testing and deploying of codes so that softwares can be released faster and more reliably. They are also tasked with activities such as debugging of monitoring processes and applications. And of course, we know that applications are bound to experience downtimes, and they are also tasked with um, basically it's about how fast and how fast they are able to resolve downtimes for applications. And most of these tasks are easily being done by being automated. There are some activities that are being repeated or that might be repeated, and it might require you to SSH into your server. Instead of going through most of these repetitive tasks, they can simply be automated. And an example of that is your CI/CD, continuous integrations and continuous deployment. How this works is when you push your code to your GitHub branch, let's say your main branch, instead of you having to SSH into your server and then having to pull your codes and then having to install necessary packages and building your application, you could simply write a code, a deployment script that basically SSH into your server automatically, and it builds your file and then it serves your application as a file. So instead of having to go through all of those repetitive activities, you can simply automate them. Now, when we are talking about a cloud person or a cybersecurity expert, these engineers basically are more grounded in designs and how cloud infrastructures are. Some of our cloud infrastructures are Google Clouds, Azure, or AWS, and they help in protecting our systems, networks, and data from threats. And we also have an aspect of cybersecurity, which is ethical hacking, but probably not going to get into that now. So basically, they help to protect our systems from attackers, and they help defend against them. And for cloud engineers or cloud architects, they help us figure out how best to use cloud services. We have some of our cloud services are serverless functions, or it could be our databases or load balance balancers. They help us figure out the best ways to use most of these services. Yeah, so hopefully I've been able to shed some light on your question, or if there's any follow-up question you have for me.
Oh no, it's okay. I've gotten the information needed. Thank you.
Great. Yeah, you're welcome.
All right. Thank you, Ogogo. Thank you, Adebobola.